All right. Okay, hello everyone. Today's session will continue with module 8 to 10, checkpoint exam. Module 8, which is the network layer, 9, address resolution, and 10, uh, basic router configuration, I think. So I think basically that is what is covered on the three chapters that we're going to be dealing with today. Right. So we're on number 17. Let me see. Let me see. Okay, my screen is proper. Right. What routing table entry has a next hop address associated with a destination network? So routing table entries, maybe we can start with the types of routing table entries that we have. I think in DOS are and what do they mean? A routing table, starting with that, dominance comma routes S, which are going to be used by a router. So if a router wants to communicate with other networks, it needs to know what are the other networks that I want to communicate with, right? So if I take a look at this router R1, let's call it R1, its routing table, what is it going to show? It is most likely going to show this network right here. It is going to show this network right here. And if it has the capability to learn about probably other networks. For example, it can learn about this network here. It can also learn about this network. It can also learn about this network. When we are talking of learning about networks, that's where we are talking about routing protocols like OSPF, which are used to learn about my routes are beyond directly connected networks. And when we're talking of directly connected networks, and my networks are getting something like these ones. These are directly connected networks because they are very direct to the route. So when we talk of my entries, we talk of my directly connected entries. These two, my routers are my interfaces a router. My networks are directly attached by my interfaces a router that will consider is routing table. So those are directly connected routes. Then when we talk of local routes, when we talk of local routes, you see the local will be the IP address of this interface here. This interface, these two interfaces. Ukavhura routing table rako, pane inenge yakanzi L, and you see is the IP address of the default gateways, if I can say no. The interfaces in this example are up. Then we have remote routes. Remote routes, ndoma route akaita, for example, this one. This is a remote route. This one, this is a remote route. Because it's not directly connected, that's another different network that would love to reach from R1. So I think basically that summarizes my routing entries at Aribo. And if we go back to the question, what routing table entry is associated with a destination network? Right. So you see, I am directly connected. They are not associated with any destination networks. My local routes not associated with any destination networks because all of them anenge ari paroute ipapo, they are directly connected. So those zvinobudisa mauya, right? Leaving my remote routes. So if we want to send anything to a destination, we can only send to a remote route from a given route. I hope chirungu chirikubatika ichi. We can only send to a remote route. Kana ndiri parouter, where do I send some packets? I send some packets to another remote network. A router, it doesn't consider local networks. Switch considers local networks. A router, it considers remote networks. Right. Right. Let's move to number 18. Number 18. How does a host ensure that their packets are directed to the correct network destination? How does hosts ensure that their packets are directed? Okay. Let's look at answers. They have to keep their own routing table that contains a route to the loopback interface, a local network route, and a remote default route, right? What is a loopback interface? What is a local network route? And what is a remote default route? Keywords, I think we need to look at those. Right, number two, they always direct their packets to the default gateway, which will be responsible for the packet delivery. That is not always the case, right? Let's look at all the answers. Those who choose the answer at least niggas the proper. See, they search in their own local routing table for a route to the network destination, address and pass this information to the default gateway. Then lastly, they send a query packet to the default gateway asking for the best route. This never happens. There is no query packet that is sent from the host to the default gateway. Right. A little bit of participation. Ndichimbofunga. Oh, how do hosts ensure that their packets are directed to the correct network destination? How does that happen? Who do we have? Para and Lloyd, participation.
Apa ndisitomboona anything to do with IP because are we just but we are just assuming that it's not a local it's not local
Yes,
communication here.
it's definitely not local. Can I find a router? Then we are talking of remote communication. Can I find a router? We're talking of remote. Now the question is, how do hosts ensure that their packets are directed to the correct network destination? Host, right? Let's have something like this. So this is a LAN. This is a LAN, right? SR directly connected. So there is no need here in my router. Let's do this instead. Right. How does a PC terminal? How is it able to send a packet to PC number 2? What helps PC number 1 kuti ikwanise kusvitsa packet ku PC number 2? Right. What helps is the routing table. That's number 1. The routing table is responsible for knowing my networks are remote. Ndo panoliswa all the networks dziri kuzivikanwa nerouter. This router here. Right? Routing table inotiudza kuti tine network iri apa inonzi network A, tine network iri panapa directly connected inonzi network B. That's what the routing table is responsible for. Right? My hosts, they also have their own routing tables. Right? Then we have a connection to the loopback interface. This one, I'm not so sure how it helps. Let's skip this one. A local network route. A local network route, if you want to communicate locally, and a remote default route. A remote default route, if we want to communicate with remote networks, we need a default route. most probably via the default gateway. So I think those are the piece of information that a host requires so that it be able to send information to remote networks. I think this one is the closest answer, mainly because of this keeping a local routing table with local network routes and remote default routes. For me, this is the closest answer, right? The other ones, maybe let's eliminate them. They always direct their packets to the default gateway, which is responsible for the packet delivery. The default gateway is not responsible for the packet delivery. The default gateway is just a gate out of the network. Rinenge risingatozive kuti kuri kuenda information ndekupi. Chinoziva kuti kuri kuenda information ndekupi. Information inotozikanwa kuti iri kuenda kupi from this PC. Panotosendwa information, panoitwa encapsulation, panoiswa IP addresses, the destination and the destination IP and the source IP. Ndo panozikanwa kuti packet riri kuenda kupi. Destination yaiswa, then kana iri outside the network, zvinoda kuti chichangopfuurawo nepadefault gateway. Then the router will decide which is the best path to the destination network. How does it decide? It looks at its routing table. Right, as a routing table, then it knows I'm going to forward to this router, which knows the destination network, something like that. So they always direct their packets to the default gateway. That is not always the case. Which will be responsible for the packet delivery is not. What is responsible for the packet delivery is the router itself. Ndo rinoziva the destination networks. Right? They search in their own local routing table for a route to the network destination address and pass this information to the default gateway. They search in their own local routing table for a route to the network destination address and pass this information to the default gateway. Right. If you understand the process, how packets are routed, it will be much easier to eliminate answers like this one. Because how does information go from 1 to B? I think let's go through that process. How does information go from, can I have this? Need some space, Nyana. Right. So if we have a remote network, let's use this one. So we have PC1 here and PC2. Understanding what happens with respect to routing is very important. Right. Kana tichibva paPC1 panapa, ndo panototangira data encapsulation, where our data at layer 3 goes the destination network, the ERI. So now let's say the destination network here is 192.168. Can I not make this a bit thinner? Yeah, just a minute. Customize. I can't. Okay, let's go. So 192.168.10.0. Let's have that network. Then this end we have 192.168.20.0. So during encapsulation, the destination IP inenge yakatonyorwa 192, these are examples, is .10. Maybe yakanyorwa .10 as well. That is the destination IP address. I will send the information using the IP address of the destination device. Unlike layer 2, we can without knowing the MAC address. Then the process ARP taking over at the destination. But with the IP, you have to know what is the destination IP address. So kana taziva destination IP address, encapsulation yedu yaitika packet redu rane source ne destination IP. Iro rinobva raendeswa pa router, pa default gateway. The reason why richiendeswa ipapo because of the network ID iri panapo yakasiyana network ID iri panapo. Therefore, a packet is sent to the default route. The default route racho yaendeswa padefault gateway. Deencapsulation yoitika. Panoitika deencapsulation, the router looks at this IP address. Ikatarisa that destination IP address, it looks at this part iri, which is the network ID. Ikatarisa that part yakuziva kuti the network which I'm supposed to send information iri papo. Yaziva, it then goes and looks at its routing table. Now routing table ndo mune maentries ekuti network 192.168.10.0 tinoiziva via OSPF, or let's say static. It was configured statically as via router number 2 interface. Let's say this interface is 00 via router number 2 interface 00. This is an entry in the routing table. So what that entry is telling us, kuti kana ndiri pa R1 kuti ndisvike pane network E 10.0 iyi, I have to go via Giga Ethernet 00 kuti ndisvike ikoko. That's how a packet is sent to this interface. After re-encapsulation, a packet is sent to this interface. Kana yasvika parouter panapo, network destination is now a directly connected network. So it's very easy per process here, de-encapsulation and re-encapsulation. We can easily send our packet to this network, which is the destination network. So I think if you understand the whole movement, yekuti packet rinofamba sei, rinobva sei paposition yepahost, rozosvika padefault gateway, rozotorwa ipapo after de-encapsulation re-encapsulatwa futi. If you understand that whole process, I think it makes it easier to answer some of my questions which we are answering right now. Right, let's move. Let's go to, we're on number 17, I think. Number 17. So I said for 17 is remote routes. Tick remote routes. Then for 18, how do hosts ensure their packets are directed to the correct network? They keep a local routing table which contains the loopback interface. I'm just struggling to understand why we have a loopback interface here, but question mark there. Which also has a local network route and a remote default route. All right, number 19, which when transporting data from real-time applications, what does it mean when we talk of real-time applications? Real-time, okay, there's an example, such as streaming audio and video, real-time. Which field in the IPv6 header can be used to inform the router and switches to maintain the same path for the packets in the same conversation? Which field in the IPv6 header? Quick answers. Which answer do you feel is correct for that one?
I think I'll go with the flow label.
Why?
Because it looks as if it's more appropriate in the sense that the flow label, if I'm not mistaken, zvakuda zvichitiza aida vanhu achichazozvifunga tisati ndatanga kutaura.
Right, let me eliminate this. Is for QoS, this traffic class. I've never seen this header IPv6. Did I? Traffic class. What is that one for? Traffic class. I can't remember about that one. But the answer, yes, is the flow label. Why? Right, flow labels are in. So if you're sending like the highlighted real-time application stream video, there's a label attached to my packets, right? My packets, pacha send what they're going to be broken down my network, right? I send where ring or one packet for the whole video, if I can say. So during streaming, but my packets are going to send continuously in real time. My packets are send as you stream, my packets my send like that. It's not like you send just one huge packet for the whole video. No, Panama packets which are being sent continuously, right? My packets are being sent continuously. Kana pasina for chinchon's flow label. Flow label is just a label UNESCO on those packets. So kana if we are streaming a video A, then we label every packet video A. Tinataka label ukuthi this packet belongs to A. That is the flow label. Now what happens kana packet rikasvika parauta. My packets A saka label yakunzi A, they are directed to the same path to the destination network. Kana asina kulabeliwa, router rinosenda to the best path. There's a difference. Because a three route up, right? Let's say we're sending information from here to here, from 1 to 2, right? If the first packet dodo dai this route rikasvika up, then every packet relabeled A rinotora that same path. Ndokunge rakaiswa flow label because of the head, because of the field that runs flow label. Suppose a repo field iroro, what will happen is mamwe mapackets achauya panapa. Maybe at that given time, that is the best path which is being chosen by the router. But mamwe achauya nekuno, because at a given instant, that is probably the best path which I choose ne route. So the reason why we have flow label is so that we can label my packets for real-time applications, so that the path yatorwa the leading packets ndo path inotorwa nemapackets ese ari kutera, which makes it very good for my real-time applications. So basically that's what the flow label is. I think I've tried simplifying that one as much as I can. Next, here the traffic class. Do we have those ones by IPv6? Buddha. Right, let's go to number 20. Which statement describes the function of the ARP? I think that one is very easy. Give us an answer, number 20. Or let me eliminate the answer from someone. ARP is used to discover the MAC of any host on the local network. Question
I
mark.
think I'll go with the D.
Answer, any answers? D. Okay, question mark up. Let's look at the other answers. I think. Hello, Sharon. All right, ARP is used to discover the MAC address of any host on a different network. Question mark. ARP is used to discover the IP address. Right. ARP is not used to discover the IP address. So let's remove those ones. ARP is used to discover the IP address. No, no. So between C and D, what's the difference between C and D? To discover the MAC address, it maps IP to the MAC. Yes. It maps IP to the MAC. Definitely yes. But let's relate to my answers at Panap. Right, let's relate to my answers at apo toona kuti inonyatsobuda ndeipapo. Which statement describes the function of the ARP used to discover the MAC address of any host on a different network? This one
And
is
I
tricky.
still think
This one is tricky. Used to discover the MAC address of any host on a local network. What is the difference? Yeah, I think I've got the answer. I've got the answer in my head. Uh, Let me give you the floating board, the answers again. The answer is between C and D.
okay, yeah. Any day I will find I'll go first, then maybe Cheryl will go next. Um,
The
even
other
I,
one uses the default
why
gateway.
I'm sticking with the D and D
Uh,
is because since you are talking about MAC address, MAC addresses they have for local area networks mostly.
yeah,
So I
it
think
makes sense. Yeah, it makes sense. Sharon, what did she say? She said the other one uses a default gateway. Yes, I think both answers are true. I just want to give you something like this, right? If I'm trying to connect between PC1 and 2, ARP only works on local networks. So you will see a request can be sent over PC1 ichida kutsvaga default gateway. This is local. So ARP panapa is working local. Kana yasvika panapa, packet richasvitswa panapa. Then another request is sent to 2 kuti tikuda MAC address. This is also local. So ARP it doesn't operate between different networks. As much as if you look at it as the whole of the communication, it might seem like ARP is communicating from PC1 to PC2 in this example, but no, ARP it will communicate locally here with the default gateway, then over upper with the uh, destination host. Okay, but I think I like the one chain as well. Yekuti ukaona MAC address, there is no need yekutanga kutaura nezvema different networks. I think that might save you that kind of thinking. Right, 21. Under which
I
circumstances?
say just a quick one.
Yes.
At Saturday and then I do have a question. And we're saying ARP, right?
Uh,
Only works Mumala and DT.
uh,
So isn't cool IPv6 we use the neighbor discovery and DT?
neighbor discovery and neighbor solicitation. Uh,
Yes. There was something that I was reading. I'm not sure if I understood it, but I just want clarity on that. Where it was saying that if, let's say, the MAC address yacho is in another network, then can you just clarify that for me? Like, I don't really know how to phrase the question, but I think Dambowana Pampani, a different network where it had to pass through a default gateway to obtain the MAC address from another network.
okay, let's have the same scenario. Right, if I have the same scenario, now we are using IPv6, PC1 and 2. Are you saying if we have those neighbor solicitation and neighbor discovery, let's just say neighbor discovery, I will be able to get the MAC address of this from this point? Is that the question? Is that what you read?
Okay, after the lesson, I'll try see if I can send it in the group so that it's a bit clear. We can move on for now to avoid confusion.
No, I like confusions. I'm just trying to
no,
understand.
I think we have to really go ahead because it's a learning moment for us.
Yeah, I like confusions. Neighbor discovery. Let me see. Neighbor discovery. Let me try to explain it using this same network. I think it's now message is a neighbor solicitation. Imagine as neighbor. There are two messages.
Neighbor advertisement.
Neighbor advertisement. Right. Solicitation, ndo inoitwa device iri kuda MAC address. So this PC communication between network yatagadzira iyi. PC1 inosenda neighbor solicitation to the default gateway, to the router. Router roresponda neMAC address default gateway. Then kana tasvika takuda kutsvaga yedestination inoi. Yes. Takuda kutsvaga yedestination inoi. Tiri parouter. Another solicitation is sent uko. Then advertisement yosendwa uko ine MAC address inoi. I think it's the same thing. My explainer data ARP okay, my explainer data ARP. I wanted to say per version 4. Then in neighbor discovery, almost the same thing as well. So you see with my neighbor solicitation, the advertisement, they are still operating in this network. Then the solicitation advertisement is still operating in this same network. I think Dopa over the idea, yeah, operating in the same network. But with I think it becomes very different. Mukatarisa router solicitation and router advertisement. I think these ones can operate between my networks now, which is a different thing from a neighbor discovery issue. For the avoidance of any doubt, let's go back a little bit. Let's go back a little bit. How many minutes do we have? 4:36. Let's go look at neighbor discovery. Don't know the basic function in neighbor discovery. I'm gonna say. Can you Google like try Googling working principle of neighbor discovery, NS and NA, ARP.
Okay, so I think Ndanya also want a question yangu.
Yes.
So what I was asking is Kutanditi, we've got two different networks and it's in a default gateway yedu anditi. And then it then broadcasts, right, looking for the MAC address. So where I read Yangaishiti before anditi yasudzusa the destination MAC multi address anditi. It's got inonzi destination IPv6 SN multicast.
Rephrase. What do you
Okay,
mean?
when it then responds like
Okay, we have different
destination MAC
networks.
address.
Okay, let's
Yes.
two different networks, right? 1, 2.
Yes, two different networks.
Uh,
Yes, like that one.
uh,
Magavura. Right. So let's say your PCA, right,
sends
is looking for
is looking for the default gateway, the MAC address of that.
yes, right. And let's say PCC then is the IP address, yeah, right, with the corresponding MAC address. So where I read it says before yes also said the destination MAC multi address and the multicast address. It first sends what stores
Why
as a
multicast? Why multicast?
I was also going to ask that because I know for IPv4 it's unicast, right? But then now it's multicast.
Right. I think it becomes multicast if all my nodes are with a solicitation, they are grouped. If all my nodes are with a solicitation, they are grouped, which I know it happens to router solicitation. I think, are you sure Pamparotaron ye neighbor discover? Because there is another set of messages. This one I'm sure. This is RS and RA. So RS ma routers ese anenga akaiswa mu group which solicit marouters S anenge akaiswa mugroup. So when the response is sent for that RS, inouya iri multicast because marouters S anenge ari grouped. I'm not so sure in a local network we can have multiple devices soliciting a MAC address from the default gateway or respond on a multicast address. Question mark. I'm not so sure. Text waiona pachi. I think you can send it by WhatsApp, screenshot whatever you're reading by WhatsApp, so that
Okay.
to analyze it, because I'm a bit all over the place as well. Because in brain mango, I'm thinking we might be confusing with this one, these sets of messages, RS and RA.
Okay, that's
Can you
fine,
send
sir.
it by WhatsApp? Can you send it by WhatsApp?
Iripa Moneta Kids 9.31, the 9.31 video where they were just explaining like the neighbor discovery process.
Is the video 9.31?
And 9.31.
All right, let's look at this one. And the screen langu tapa neighbor discovery, right? Neighbor discovery sometimes. Okay, I have less than 1 minute. Let me just end this, restart, totangira pa neighbor discovery. Okay.